everyone. Today we'll talk about serverless Spark. I'm Abhishek Kashyap. I lead product management for open source data analytics at Google Cloud. And I'm very excited to have Richard Williamson and Ethan Kuehl from Walmart joining me today. Before we talk about anything, I would really like to thank them for taking the time. The use case they will talk about is very high impact, and we all deal with it every day. So in terms of agenda, I'll briefly introduce Dataproc, which is our open source data analytics platform, and talk about many new things that we are announcing today for Dataproc and serverless Spark. Then Richard and Ethan will follow up. They'll talk about the scale they deal with at Walmart, the use cases, and how they're using serverless Spark to solve them. So let's start with Dataproc. Dataproc is Google Cloud's service for open source data analytics at scale, providing you with the best price performance for your workloads. We are heavily focused on security and reliability for your open source workloads, so your customers, who are the business teams, get a rock solid platform that you have to do minimum work managing and is at the price performance that fits your budget. Being a part of Google Cloud, we strive to provide you a single end-to-end platform through seamless integrations with Vertex AI for AI ML, as well as with other data analytics products like Dataplex and BigQuery, so you don't have to do a lot of integration work. In terms of what we focus on, the focus for Dataproc is 4 key areas. One, we want to continue providing you the best price performance in the industry for Spark workloads. Second, we believe Spark should be cloud native with serverless execution. Just like data analysts can use SQL in a data warehouse without worrying about VMs, Spark should be the same way. Third, we are going to bring Spark to your data center, because a lot of customers we see can move 90–95% of their data and processing to the cloud, but a small sliver continues to stay in the data center for very sensitive data. And finally, we are continuously investing in leading edge security and compliance, because the compliance landscape is evolving very rapidly. So let's start with price performance. An analyst, ESG, did a study and found that Hadoop clusters, when migrated to Dataproc, lead to a 54% lower TCO than the Hadoop clusters on-prem. So this was the starting point. They compared us with other cloud solutions as well and found the number is not 54%, but it's anywhere between 30 to 50% because of our edge in price performance. This study is about an year old. Over the last year, we have made significant improvements in price performance. If you think about Dataproc, these are open source analytics workloads running on data in either Google Cloud Storage or on BigQuery storage. For both of them, we have made significant improvements in 4 key areas. First one is in the Spark runtime. We are making a lot of improvements to the execution engine and over time contributing them back to the open source. These are not proprietary. Second, we have optimized connectors for BigQuery storage and GCS. We have made a lot of improvements to those. BigQuery and GCS are also making significant improvements to better serve these Spark workloads. And finally, GCP is continuously evolving hardware, and we are leveraging hardware to get the best price performance for you. Now the second area of focus, which is serverless Spark. If you look at Spark today, the traditional model where you create a cluster and then you run jobs in it, IDC found that this requires about 60% of a developer's time to think about the infrastructure. What VM type do I need? What shape do I need? Will I interfere with others? How much capacity you need, etc., etc. If someone thinks that you're spending a lot less than 60%, would love to know more. I've actually talked with data scientist teams who say my job was supposed to be data science, but here I am thinking about VMs I need versus the model I need to build. So with Serverless Spark, we want to make this 100% time on your business logic. We don't believe data engineers and data scientists should be spending so much time on infrastructure management and sizing. We want you to focus on your Spark application and provide you with a serverless service where you submit your application, it runs, you don't worry about it, and you only pay for the time the job is running. You're not buying infrastructure anymore. You're not paying for startup times, shutdown times. You're just or having long underutilized clusters. You treat Spark as an API that will run your application. And architecture-wise, that's how it is built. Serverless Spark is an API. You submit your code to it. It will start off auto-scale using Spark dynamic allocation. There is no yarn. It will scale back down. All the resources will be cleaned up after your job is done executing. And we have also made significant improvements to Spark auto-scaling and contributed it back to the community. This is now much, much better than yarn-based auto-scaling. Since this is an API, you can connect from your interface of choice, be it BigQuery, be it a notebook, be it an orchestration platform like Airflow or Composer, and it will connect to any auxiliary service. You can have Dataproc Metastore, you could have a Hive Metastore in your own data center, you can connect to any of those. And this does work on different file formats, table formats, to optimized GCS connectors or with BigQuery storage as well. These are just distinct. This slide has an issue. All the logos went off, okay. That's fine. So, what are we announcing today? The key announcement today is for Spark for interactive development for data science. The first one is what you might have already heard in the keynote. Serverless Spark now supports NVIDIA GPUs. We are starting with L4 and A100 GPUs. So for a subset of your workloads, you can get up to a 10x speed up. We are the first serverless service to add support for this, for Spark, and we'll continue making it better. The second set of announcements for interactive development is that just like for batch workload, you could just submit to an API, you can now start an on-demand Spark development session. The traditional way where you keep a cluster up and running, you access its notebook, even if it's 20% utilized at night, you cannot shut it down. You no longer need to do that. Your data scientist, data engineer can log in through a notebook, click a button, start an on-demand session. It will auto-scale within idle time to live. It will be cleaned up after the user is done. So you don't have to do cost management. You don't have all these resources sitting idle. And users get fully isolated environments for their notebooks. So you don't even run into issues of one user's code making the cluster out of memory. So you get a much higher reliability as well. Interactive sessions are available through 4 key interfaces. One, we have open sourced a Jupyter plugin. So you can go to the marketplace and install a Jupyter plugin to any Jupyter notebook on your laptop in the cloud and start working with Serverless Spark from right there. Second, Vertex AI has managed notebooks. You can access them from there. And very soon, we are going to be on 2 partner notebooks as well, one being Hex and the second being DeepNote. So you can go there and use Serverless Spark as well. Okay. So here's a quick demo. This is a user on their laptop they're just launching Jupyter Lab. You get to Jupyter Lab, you can see a list of Dataproc clusters you can connect to, or you can start an on-demand serverless Spark session. You can define templates for the users to use. It will create infrastructure in the backend on demand. You can start a notebook, start coding against it. You are on your local Jupyter, but each cell is being executed on this highly parallel infrastructure that auto-scales based on Spark dynamic allocation. In this example, we are analyzing some weather data. Once the user is done, this is all cleaned up with the time to live, as I mentioned. And you can work with Python, SQL, Scala, and R through these sessions. So this is available in public preview today, will be GA in about a month. So you can go try this out. Now, if you use Spark, you likely use some orchestration platform. The most common one we see is Airflow. Our managed Airflow service is Composer. Today, we are announcing a step change in how Composer is used. We are announcing Serverless Composer. So far, you had to worry about a lot of pieces, a lot of IP addresses to use Composer. With Serverless Composer, we launch everything in a tenant project, spin up all the services that Composer needs behind the scenes. You don't have to worry about it. So your users can just focus on the DAGs. We take care of managing Airflow for you, managing all the services needed for you to run this reliable orchestration service. And you get features like this will connect to your VPC with a single click. There is no need to use a range of IPs anymore. It will use a maximum of 2 internal IPs. So with Serverless Composer, this will make your orchestration pipelines a lot easier to manage. A quick look at Spark on-premise. Some of you may be aware we have an Anthos-based appliance called Google Distributed Cloud. The idea is that if you have certain workloads that need to stay in your data center, then this gives you an environment so you can standardize services across GCP and your data center. So you don't have to maintain 2 separate stacks and operate them. Now this has been available, generally available. What we are announcing today is the availability of Spark through Dataproc on GDC Edge. So let's say you have sensitive data that cannot leave your data center. You start using cloud for 95% of your data processing. You can use the same Spark applications, deploy it on GDC Edge in your own data center, and have really low operational costs in managing Spark across 2 environments, which is GCP and your data center. Now this is a full stack. It comes with all the auxiliary services you need, like GCP IAM or logging, monitoring. So you can just install it and start using Spark the same way as you do on cloud. This is available in private preview, and you can talk to your sales rep if you're interested. A quick view on security and reliability. I know this is not something that sounds very cool, but this is very, very important for a lot of our customers. We have very, very advanced security features like encryption using your keys, but using an external key manager and requiring access justification for key access. Similarly, you can control who supports you, who sees your logs. You can enforce all policies that encryption keys must be used, and you can connect to your own ID like Active Directory versus using GCP IAM. And finally, for data residency, we now support it at rest, in transit, and in use. So Dataproc is now available to be used in a lot of places where compliance requirements are very high. The next announcement we have is that Dataplex, which is our governance platform, now supports table-level lineage for Spark as well. So if you use multiple GCP services, you can go to Dataplex and see lineage for BigQuery, for Dataflow, and now Spark. So you have a single place where you can see or lineage, and this works not just for SQL, but for Spark in other languages as well. And so I have to go really fast to give all the time to Walmart. So we are happy to talk about these offline. If you deal with stockouts, we have a new feature for Dataproc where you can define multiple VM shapes. And when we create a Dataproc cluster or auto-scale it, we'll pick the best one based on availability. So in peak times, when sometimes these operations may have caused reliability issues with flexible VMs, you will be able to get a much more reliable service. To give you an example, let's say you wanted high memory machines, but RAM was in shortage. You also provide us with a shape with smaller RAM. We will use that shape and make it happen for you. This is available in public preview. You can start using it today as well. And the last one on reliability is Dataproc Metastore. So we have a fully Hive compatible Metastore, which we are announcing to be available for active disaster recovery. So you can now deploy Dataproc Metastore in multiple regions in an active configuration. It will sustain a regional outage because metadata is critical. Your applications will continue running. It comes with horizontal scaling, so without any downtime, you can scale it up and down depending on your workload. And it supports fine-grained access control. So rather than having many metastores, you can have a single one and you can control access among your users and business units. And with that, I would like to invite Richard to kick it off for Walmart. Thank you, Richard.
Thank you, Abhi. It's been a pleasure working with you and your team over the last couple of years to scale out Apache Spark for Walmart's use cases. And great to see everyone here. I lead the applied AI end-to-end machine learning engineering team for Walmart. We support over 100 data scientists running lots of models on Apache Spark for us. I started with Walmart in '96 as part of the first AI team within Walmart, so I've seen lots of growth in the AI space over the years. The first half of my career was spent as a data scientist, writing optimization and forecasting models. And then in 2009, I shifted focus to build out the first Hadoop clusters at Walmart. And since then, I've been helping data scientists scale their machine learning problems ever since. So today we're going to talk about serverless architecture for API-driven workflows. But first, just a bit about Walmart. As our customers' shopping patterns have changed, we've been quickly adapting to help serve our customers better. We understand now that our customers' time is more valuable than ever. So we've introduced things like online pickup and delivery within our stores and scan and go at Sam's so you can walk right out without going to a register. So these are just a few of the ways we've been enabling our customers to save time. With the tremendous business scale that we have at Walmart, which you can see from this slide, we obviously have to build technology platforms at massive scale. Our team currently focuses on Walmart US, which has over 5,000 stores with a broad item selection. So you can quickly see how the scale matters. Open source platforms like Apache Spark and Apache Hadoop have helped us mitigate vendor lock-in for over a decade now. That's allowed our business to scale for these needs. We now run concurrent models using hundreds of thousands of cores, and we work with tables up to 100 trillion rows. That's 18 petabytes in a single table. Our area's platform of choice for this massive scale is Apache Spark, and we have leveraged GCP Spark Serverless over the last 2 years since it was in preview mode. I've been very thankful to Abhi's team. We actually went to production right as it went to GA with our first use case. And we've had no downtime from it. Our architecture team works across 5 ML OR pillars. supporting various business domains from supply chain to merchandising. And we built this end-to-end model serving solution. We've been teaching our data scientists to start using PySpark versus Python right from the get-go so they don't have to translate later. We use the flexible architecture template, which you can see here. Our infrastructure supports near real-time OR models, which do not follow the typical model training and inference structure. So each model is computed dynamically, and results are obtained at the end of the run. So if you look at the diagram here, you'll see the application API we'll call our integration API hub. And then from there, we'll pick the specific plugin. Those plugins will kick off a Spark serverless job and return the results back to the business. The serverless architecture has allowed us, instead of relying on the one cluster, many jobs problem of having contention across those jobs, to now just have a single scalable platform in 2 dimensions. So basically we can scale the number of concurrent jobs easily, and for each job we can scale out to thousands of cores per job. And then here's how we think about our MLE development lifecycle. So as you saw from Abhi's slide on the interactive sessions, we've been using some of those in preview. So some of our data scientists will go use those sessions. Others will be working on a local Jupyter notebook. The key, obviously, is to give them a clean slate where they can start developing without having lots of constraints from tech. And then within there, they'll build out their data frames from either CSVs or BigQuery. And then once they're ready to move to production, we will help them within our environment to scale those algorithms to PySpark using things like the Pandas UDF. And I think this architecture will make a lot more sense if I turn it over to our team member, Ethan Kuehl, to show a use case.
Hello, everyone. My name is Ethan Kuehl, and I'm a senior data scientist on Richard's Applied AI Architecture team. I've been with Walmart for the past 2 years, and in that time, we've seen our MLOps and MLE pipelines grow exponentially. And today, I want to help show how serverless Spark was able to drive that growth. I have the great privilege to talk about one of our flagship algorithms that I have worked on for the past 2 years called store assortment optimization. It recently won the Informs Prize for Operations Excellence. And from a business perspective, it is a tool that delivers a locally optimized, space-aware assortment recommendation. And what that means is we are actually optimizing the number and type of items in a store based on merchandising information and forecast data. You can imagine how this is critical to Walmart's mission of serving our customers the items they want at the price they deserve so that they can live better. Specifically, where store assortment optimization is used is with our merchants. And they usually use 3 adjectives to describe this algorithm: fast, transparent, and strategic. It is fast. It has to be able to deliver an assortment recommendation in less than an hour. Transparent. We have to be able to show how our current store's assortment compares to our optimized assortment. And strategic. On top of all this, it has to be able to adhere to business and supply chain constraints. On the diagram on the right, you can see how merchants think about implementing a new assortment with this tool, going from inputting their data and then just seeing an optimized assortment, and then comparing afterwards. And under the hood, you can see we're using forecasts and calculating incrementality, which is the uniqueness of an item, applying constraints, and then running our model. Now, here comes the overwhelming part. To highlight just how overwhelming some of these SLAs were, I decided to just put a ton of words on this slide and try to force you to read them in a minute 30 or less. So from our perspective, a store assortment optimization is a batch operations research optimizer. What that means is we are using a batch of stores and we're trying to calculate the assortment for every store individually. It has to be able to scale to 4,600 stores and 100,000 items per store. Run under 1 hour. Support up to 100 simultaneous requests, and all the while minimize our costs. You can imagine how much my colleagues and I were sweating when we read this. But really, serverless Spark saved us quite a bit here. It enabled us to stick to our principles of everyday low prices, deliver that time-optimized result, deliver persistent results with the BigQuery connector and the GCS connector. And then it is scalable in 2 dimensions. One, from a model level, where we are able to scale one run to all 4,600 stores. And then 2, enable a high throughput of requests at the same time. So as Richard was talking about Integration Hub, we really framed that idea around a clean architecture, plug-in adapter type architecture. But it also adheres to Michael Scott's Keep It Simple, Stupid methodology, and I'll show you how it does that. Starting at the bottom left corner, we are getting a request from our business partners for an optimization. This request contains details of what we want optimized and all of the merchandising data we may need. That request then goes to our service mesh layer called Integration Hub that is built in-house and which routes the request to the correct plugin. That plugin logic then uses our merchant information to dynamically set the PySpark configurations required and able to meet all of our SLAs. Once that plugin dynamically sets those configurations, it posts that information up to our first feature store, which contains our merchant metadata, our PySpark configurations, and the third thing I haven't talked about yet, our model repository. Integration Hub does not actually post the repository. The data science team and our CI/CD pipelines are responsible for that, but it is nonetheless included in our input feature store. Once our metadata is pushed up to that GCS bucket, Integration Hub then sends a RESTful request to the Serverless Dataproc Batches API with the metadata URL required for that run. And I'll go a little bit more into detail about what's actually happening in this component in the next slide. But for now, you can kind of think about it as both an ETL pipeline and our model serving pipeline. Finally, when our model finishes, it posts all of our pre-processed data, our output data, and then enables our end users to look at dashboard views of our results and decide if they want to use that assortment. Data scientists often also use this information for that CI/CD pipeline and to identify anything that may have gone wrong in the run. So now digging a little deeper into that serverless Dataproc component. Serverless, the batch itself can be thought of as an individual component of a model serving pipeline or as the entire end-to-end serving infrastructure. The diagram on the right illustrates how this is possible. In the topmost layer, we have our pre-processing data ETL. So this is a pipeline that leverages PySpark's scalability and distribution to most efficiently perform our ETL functions. Now the second layer is where it gets a little bit more interesting. That second layer can go one of two ways. We can either use the right pathway, which leverages the exact same PySpark configurations as that first ETL pipeline, or on the left side, we can actually trigger a new batch that has new PySpark configurations and enables us to maybe build bigger models that could not use the same PySpark configurations as a typical ETL pipeline. One example of this is going from having a CPU handle one task to having 16 CPUs handle one task for one model. And then that third layer is exactly the same as that pre-processing layer. The only thing different again here is whether or not it is using the PySpark configurations from that previous layer. This architecture has enabled us to host a wide variety of operations research models scaling from 100,000 variables all the way up to 13.5 million, which is a huge feat considering this all needs to be done under an hour. One amazing component about Serverless Spark is its horizontal scalability. That enables us to get that time efficiency and that cost efficiency component that Walmart really needs in order to operate efficiently. For one job, we can see a range of 2,000 to 6,000 CPUs being dynamically scaled based on the various requirements that Integration Hub has provided for that job. So now I would like to go into some of the benefits that we have received from transitioning to this model serving infrastructure. Some immediate benefits: cost savings, huge. We were able to radically change our cost model for serving operations research models. The second one, infrastructure reliability. With a static approach, we often faced lots of downtime, having to maintain our clusters, and just really were not able to keep a 24-hour reliability that our merchants sought. And then fourth, an increased request throughput. In our previous architecture, the static data proc cluster architecture, we were only able to serve about 12 models at a time. We have now increased that to about 100 models simultaneously. Some benefits that were realized over time. One of my favorite, reduced carbon output. The ephemeral nature of these clusters really has enabled us to be more conscious of how we are using our servers. The second one, supercharged Spark. Again, that ephemeral nature is huge in being able to transition our PySpark configurations to use more disk and less RAM for super heavy memory operations. For example, we once had a greedy algorithm that had 50 window operations, 50 group by statements, and we were running out of memory every single job. And as soon as we were able to start using that checkpoint with Serverless Spark, everything started working. And that's really difficult to use with a static cluster. Third, eliminated on-call infrastructure support. Huge. I can't tell you how many more hours of sleep I've gained. And finally, the scalability of our continuous integration and improvement pipeline. With the development of our interactive sessions, thanks to Abhi, we have been able to radically change how we think about actually developing large-scale models and ETL pipelines, and it integrates seamlessly with the actual serverless data proc batches. So what's next for data proc at Walmart? We really are excited to leverage the GPU accelerators on serverless data proc. This will help a ton, both in our PySpark operations, but also if we ever migrated our models to using some of the PySpark native languages. Second, standardizing this serverless architecture. As we have built out Integration Hub, and store assortment optimization was really our first use case, we've onboarded about a dozen new models onto the same architecture, but we've got dozens more to go. And then third, applying Spark Lens insights into how we think about our PySpark configurations. It's really useful for setting a correct dynamic allocation ratio or for determining the maximum number of executors for your SLA. At the end of the day, like I said, it's all from an MLOps perspective, it's all about the SLAs, and so having that information is always helpful. And finally, our applied architecture team is hiring. Please, please reach out if you're interested. And I would like to invite my fellow speakers back on stage. Your feedback is greatly appreciated. Thank you.